to Damian. Damian's here from, sorry, I forget if it's GetFlex or FlexVec.
Oh, Flex is the tool, and then the retrieval kernel is FlexVet.
Got it. So he's going to tell us all about that and about actually finding the things you've been talking to AI about.
Exactly, yeah. I'll just share my screen. Thank you for the introduction. It's been a pleasure joining in on the conversation as I've been to the last two of them, and I've met great people. So thank you for the opportunity to talk about Flex. So Flex is a search and retrieval tool for AI agents. I'm going to first give a quick overview of what Flex is. I'm going to explain why memory is important for AI agents, why retrieval and memory are one and the same thing. And then I'm going to give a few demos of using Flex, and then we can end with a short Q&A. So what Flex is, it's an open source search and retrieval tool. It's on GitHub right now. We'll have a link available at the end. It turns agent sessions into searchable working memory. So if you install Flex right now, it gives you a MCP server to search all of your Claude Code session history. So you can ask it about what you did last week, what you did yesterday, and retrieve information from your existing sessions. It's also extensible for any structured data set. So if you have an Obsidian vault or you want to download some financial documentation and build a knowledge base and give your agent the ability to search it, then Flex is perfect for that. So I'm going to talk about why memory matters for AI agents. First of all, when we think about memory, we often first think about remembering something. The act of like sitting down and thinking, oh, where did I leave my keys? Or what did I put in my tomato soup 3 weeks ago to make it taste so good? We think about remembering something. And remembering and retrieval are the same thing. When you're remembering something, you're retrieving information from your memory. But memory as such is much more fundamental than that. It's necessary for effective work. So you can imagine if you were to hire an employee and they were to forget everything they learned at the end of every shift, they wouldn't be able to do very effective work. They could do simple tasks that you would be able to teach them in the first hour of each shift, but they wouldn't be able to do complex work. Agent conversations are the same. So every new conversation is like onboarding a new employee. There are some sort of rudimentary memory tools that ChatGPT and Claude Code and Claude.ai are using, where they'll bring some facts about you into the conversation, or they'll compact and summarize the session and pass it off to the next session. But the fundamental atom is still the same thing. The session starts from scratch in some sense, and you have to onboard that agent to the work at hand. Now, complex work depends on lineage. So not only do you want to remember what the last conversation did, but you want to have a map of the work that you're doing. So to give another sort of workplace example, if you're building an apartment complex, you'll build out or write out maps of each floor, where the plumbing is, where the heating is, where that is. You can imagine that if you had a team of workers come to work on the apartment and you didn't give them a map of the apartment, it would be very difficult to fix the plumbing. So when you're working with AI, you want to do the same thing. When I'm working on a project, I'll have a map of the code base. I'll have different documents that explain the code base to each agent. And then I'll also have a lineage of each change that we make. And I'll pass that entire packet of information to each subsequent agent. So it's important to be able to do any task memory. I'll give a few examples of using Flex so we can understand really what it looks like. So in this conversation, I'm using the terminal interface for Codex, and it's just going to search my session history. And if you were using Claude Code, it would do the same thing. I'm going to ask it to find the rationale behind a file that we created. it's going to search that file. It'll find the session that wrote that file, and then it will read parts of the conversation, the last maybe 15 messages before that, and then some parts around it to understand why we created that file. The first thing it does is it orients itself on the knowledge base. So like, what can it search on? And then it searches for that file. It gets the story of that session, and then it does some granular searches on that session to pull out user messages, assistant messages, and then subsequent file writes to that file so that it can compile a rationale or like a lineage of that file. Now, I'm not expecting that you'll read all of this, obviously, but basically, if you are working with many, many agents, they create a lot of files. You have rationale for why those files were written, and they're very important. If I were to work on this code base or this file, I would pass this information to the next agent in the same way that I would pass a map to the team of plumbers who are going to work on my apartment complex. So what Flex gives the agent? Searchable history of your sessions, files, prompts, and tool calls. There's also a few things under the hood. So it gives a stable identity to your files, your projects, your repos, and URLs that you visit. So if you write a file, you rename it, and you move it, Flex tracks that. It knows it's the same file. And then the interface is SQL. It has keyword search, semantic search, and it's all local and SQLite. I wrote a paper. It's on archive. I won't go into detail on the retrieval kernel FlexVec, but if you are interested, you can read on that. There is a slight kind of like novel implementation of semantic search where your AI agent can find information that's similar to something, but suppress information that's similar to something else. So if you wanted to find information that's similar to queen, but not king, you could suppress one and retrieve the other. Here's an example of just using Flex for Obsidian. Obsidian is a note-taking app. It has a bunch of community plugins, and there's a public Obsidian vault with all of their documentation and information. So I turned that into a Flex cell or knowledge base, and then I had Codex search it to find me 3 AI plugins that Obsidian has that I could install. So it has a bunch of parameters that it can search on. It searched for files that were in the plugins folder that had the keyword AI or artificial intelligence, and then it gave me 3 plugins. But this is just showing that you can apply that same level of structured retrieval to any knowledge source. And the final example that I'll give is a workflow that a lot of people are doing now where they'll have a lead agent or a project manager agent or a CEO agent that's orchestrating and collaborating with other agents. So you can see at the top of the screen, there's 1, 2, 3, 4, 5. So those are 5 different conversations that I have open in that tab. And the lead is coordinating with the other ones. What I am going to ask it is to use Flex to read the last 3 messages of each of those sessions, summarize what they did, and then propose the next work to do. So it first gets their session ID, and then it searches their session and reads the last 3 messages of each of them. These videos are at 1.5 speed, by the way. So this is about 30 seconds in so far. If they were full speed, the talk would take a lot longer. So. So with one query, it was able to read the last three messages of all four of those sessions. So you could say something like, hey, find the last three conversations that were speaking about marketing, read the last five messages of them and summarize what we were doing. Workflows like that. But it summarized it and then it gave us a next task. So why this matters: memory, knowledge, search, and retrieval are one and the same. If you want to give your agent memory, you need to give it retrieval. If you want your agents to be working well, you have to build out maps of your code base, of your projects, and track lineage so you can keep them on track and onboard new agents. Each new agent is a new employee. And so Flex gives you tools to search your existing conversations, but then also build out knowledge bases for other structured data sets. So that's the talk on Flex. And if we have any questions, I'd love to take a few, but I know that we're excited to get into the breakout rooms. So thank you.
Great, thank you. Anyone, questions? Put up your hand and we'll let you talk. Okay, Kevin, where'd you go? I'm trying to figure out where you are, Kevin. There. And I'm asking you to unmute. All right, Kevin.
Yeah, so how have you considered competition in all this?
In what sense?
Like, who are your competitors?
Yeah, so there are a couple retrieval kernels similar to FlexVec, like PG Vector, for instance. The implementation of SQL vector retrieval is different from theirs. So one, it's innovative. I wrote a paper on the approach. And then for session search, at this point, no one has Claude Code session search that's useful. So if you wanted to be able to search your sessions, Flex would give you that opportunity. There are other people in the space, obviously, for vector retrieval. Flex is exceptionally easy to set up a structured data set and get SQL vector retrieval on your knowledge bases, your coding sessions, and things like that.
So who's been able to critique your work?
I've put it online. I've shared it and gotten great feedback. And I would love to get your feedback if you have any ideas or any thoughts.
Do you have a Discord?
I do have Discord, yeah.
Yeah,
Do you
put
want
it in the chat. Thank you.
Yeah, of course.
All right. Thanks, Kevin. And Chirag's got his hand up. Could you unmute
Yeah,
Chirag, please? Yeah.
yeah. Hi, Damian. I have a question. So,
Please.
how you are different than we have something known as phi data, right? You might be aware of, we have different multi-agent orchestration in place. There again, we have something databases like PG Vector, Quadrant, Pinecone, Lance, and all. In that
Right.
also they have this memory retrieval and all those things which Flex is providing already. It's there. My question is, what is the what is your selling point, or let's say what is the framework which is different from apart from phi data or Creo AI or something like that?
Yeah, thank you. So I wrote a paper on the unique approach that I took to retrieval on Archive, but there's two things. One is the query materializer pattern that I developed for this that allows you to pre-filter using arbitrary SQL. So PG Vector doesn't allow you to do that. A SQLite Vec doesn't allow you to do that. You can have a pre-filter that surfaces a candidate set for similarity search using arbitrary SQL. So this allows a great level of flexibility, which gave root to the name, for any SQLite database that you want to do vector search or retrieval on. That's why it works so well with Obsidian, Flex, Obsidian, Claude Code, Codex, and numerous other structured data sets. Another difference is the approach that I took to similarity search. So most vector retrieval implementations will use an approximate index, and that hides the score array in service of optimization for hundreds of billions of documents. So if you have a knowledge base like the World Wide Web that has 100 billion or like 10 billion documents that it needs to search, what you want to do is you want to approximate your chunks of data so that it's not computing similarity for all, let's say, 100 billion documents. For local knowledge bases and memory, you're never really at that level where you need an approximate index. So for 500,000 chunks of data, which is like 6,000 Claude Code conversations, you can use brute force similarity search, which is what Flex does. Now, when you do that, you can expose the score array as a programmable API surface. Now, what that allows you to do on top of that is arithmetic operations, such as suppression,